Hello everyone, today we're going to talk about estimation. In this video, we're going to talk about the difference of point estimate and interval estimate, determining the point estimate for population mean given different samples, determining the interval estimate for the population mean given when the standard deviation is known or not. Now, what is estimation? Estimation in statistics and probability is a process of approximating the value of the parameter, aka the data under the population. This is done by gathering samples and using the data or statistic to estimate the whole population. There are two kinds of estimation, point estimate and interval estimate. Let's start off with the point estimate. Point estimate is a specific numerical value of a population parameter. The sample mean is the best point estimate of the population mean. For example, there are approximately 90 candies in a jar, or there are approximately 60 people in a classroom. Now let's say a CEO took the amount of time of a random sample of his employees to finish their work. A sample of 16 employees were taken into account in the following time. We have sample group A, B, C, and D, all having different samples of the following time of when they can finish their work. In determining the point estimate, we calculate the mean of each sample group. To calculate the mean of each sample group, we find the average of each sample. So the sample mean of sample A would be 1.63 hours. The sample mean of B would be 2.25 hours. The sample mean of C, 2.13 hours. And the sample mean of D is 1.75 hours. So how did I get these? Basically, I added each and every number of each sample, divided them by 4, and I got with the answer 1.63 hours, and the rest goes on. Basically, if you want to find the mean, you have to find the average of each sample group. A little exercise for you guys. Let's say that Roy sells a bottle of Coca-Cola. He says that each bottle is 500 milliliters, but his rival Sam wants to attest that claim by taking 3 samples of size 3. The results are as follows. Determine the point estimates. Now you can pause the video and you can try it out for yourself. The next clip would be the finished solution and the point estimate. If we're right or wrong in answering this is how we do it. So we add 500 ml and 500 ml and 492 ml divided by 3, and we got 497.33 milliliters. Same goes by the other sample groups. We have 497 plus 495 plus 492 is equal to 494.67 ml. Basically, that's basically the average. So if you got this, then good job. Now let's move on to interval estimate. Now what is interval estimate? An interval estimate is a range of values that may contain a population parameter. For example, there are approximately 90 to 100 candies in the jar, or there are 90 to 100 police officers in a precinct. Now when the standard deviation is known, in determining the interval estimate for the population mean, the normal distribution will be used to determine the lower and upper boundaries. But first, let us know what's the concept with the normal distribution. We call it the confidence level. This is the confidence level normal curve. We can see that we have the values 1.645, 1.96, and 2.576, and inside this area, 90% confidence level, that is how 90% sure that the mean is inside that area or estimate. And when you have 95% confidence, that is also where that is how 95% sure that the interval estimate is there, or the mean is inside the interval estimate. Waiting for the interval estimate when the standard deviation is known, you gotta take a look at the formula. So we have x bar minus quantity z alpha over 2 multiplied by the sampling error less than mu, or the mean, less than x bar plus z alpha over 2 multiplied by the sampling error. In this part where the quantity z alpha over 2 multiplied by the sampling error, we call that the margin of error. Now, what is the margin of error? The margin of error is the difference estimate and the true value. What's different from the sampling error? The sampling error is the difference of the x bar and the mu, or the population sample and the mean. And it is the standard deviation of the sampling distribution. Let's say a businessman wants to assess the average loss of his company throughout the months of operation. According to his accountants, in the last 5 years of operation, the business incurred a loss of 20,500 pesos. If the data is normally distributed with a standard deviation of 2,300 pesos, what is the average loss of the business throughout its months of operation? We're gonna use here 90% confidence level. In determining the interval estimate when the standard deviation is known, you have to look for the given. So here we have the sample mean, which is 20,500 pesos, and the sample size, which is 60, and the standard deviation, which is 2,300 pesos. And we're going to use the 90% confidence level. So if you can recall, we used the formula for the interval estimate when the standard deviation is given, which is the sample mean minus quantity of the critical value of 90% confidence level. If you can recall that there was a 1.645 critical value in the graph, multiplied by the sampling error, less than the population mean, less than the 20,500 pesos, or the sample mean, plus the critical value and the sampling error. So here we have the interval estimate, which is 20,011 and 55 pesos, less than the population mean of less than 20,988.45 pesos. So that's how we get the interval estimate in 90% confidence level with the standard deviation given.
Hello, I'll be teaching you how to find the interval estimation when the standard deviation is unknown. If it is unknown, you use t-distribution, you use sample standard deviation, which is denoted to S instead of the standard deviation, and you use degrees of freedom. And this is the formula that you will be using to find it.
Here is an example of an interval estimation when the standard deviation is unknown. Even though the standard deviation is given, we don't know if it is for a population or the sample mean. Given from the example, let's say that we were given a 90% confidence level. How did we get the t-score? To get the t-score, you minus number of samples to 1. So it will give us 19. 19 is the degrees of freedom, and since we are given a 90% confidence level, it gives us a 0.10. So that would give us 1.328, which is the t-score that we used here. So the answer for this is 19.87, and the answer for the other one is 20.13. That is the answer for the interval estimation of our given example. The example from earlier, try and find a 95% confidence level for you to know firsthand how to solve for interval estimation when the standard deviation is unknown. Feel free to rewind so that you can understand much more on which given you should use to put in the formula. This is the answer to our question. Thank you for watching our video, and I hope you have learned many things.